Hello everybody, in this video I will introduce you a very simple but very interesting distributed system. This system consists of one server program and many multiple clients. So in this system, the server will assign multiple tasks to each of the client connect to it. And then the client will do those tasks for the server. And after they finish it, they will report to the server so that the server can manage the task for all and manage the cooperation between the clients. So why I want to design this kind of system, because once upon a time I was faced with a problem like this. So I have a lot of URL and I need to download all these URL one by one, and apparently it will cost a lot of resource and time if I do it on one computer. Even if I use multi-threading, the speed of downloading is limited. So a smart way to do that is I download all these URL with multiple computers. But if I do it manually, then it wastes a lot of time and it's quite hard. You will find a lot of problems there. So I built this system which can help me finish this kind of task. And what is more, downloading URL is only one functionality. You can actually define your own function that you want the client to execute, and you can send the resource file to the client, and let the client read those resource file and do different kind of tasks. So this is a very flexible system actually. So here you need a resource res file to record all the tasks you want the client to do. And in this test file will be sent to the client, and the client will call the run function in the text file, in the test file.py. Only the run function. And in this run, and also the server will send part of those tasks, those URL, in this case, to the client. And in the run function, which is running on the client, it will open the resource res on the client and read the URL line by line and download it one by one. So this is basically what we will do. Of course, here the task is download, so you can change it to any kind of task you want. You can play around with this system. This is actually a very simple system. I haven't dealt with the security problem and other problem, but it is actually working now. So if you just want to do something simple or test or something like that, you can try this system. I will put it on my GitHub. So here is the server side. Let's see the client side. The client side is quite simple. It only has 3 files. Client.config, in which the IP address of the server and some other protocol message will be recorded in this file. And the client.py is the most important one. It has a main function here, and also there's a task file.py here, but you can write anything here. You only need an empty. You can delete all of this, because every time when the client connect to the server, this file will be updated. So you can just leave an empty file there. Okay, so what the client will do is, first it will try to connect to the server. Once it is connected, it will request the task from the server, and then by requesting task, it means the server will send the resource. In our case, is the URL list. In our case, it's actually 5 URL list, because we defined our subtask number equals to 5 in our server. So it will send you 5 URL, and then also update the task file.py. Once this task has been done, and you can call the execute task, and this one will actually call the run function in task file.py. And then because the executing process may be quite long, maybe very long, and the connection between the server and the client may break in this process. So after that, after executing it, you may need to reconnect to the server and then report the result to the server. Yeah, if something bad happened and your program break down during this process, you will not lose all of your days, because for all those URL have been downloaded, it will record it. It will actually record it in a buffer file. So next time when you restart the client, you can just report the result to the server without re-executing all the tasks. So here I will demonstrate you the performance of this system. So it's very simple. Just start your server by calling these two lines of code. Okay, our server has already started, and then we will run our client program. Okay, successfully connected and task received. By the way, this client is running on a virtual machine, Mac virtual machine, and the server is actually running on Windows. So yeah, you can think that they are running on two different machines. Okay, successfully received. It seems that, yes, as you can see, the file has already been downloaded on the client side, and you can see the result buffer. This resource storage, you can find 5 URL there. Okay, what happened if we re-execute the client program? Because it has already successfully reported to the server now that this 5 URL has already been finished, so it will assign 5 new URL to other clients which try to connect to the server. So as you can see, when we run it for the second time, instead of downloading the first 5 URL, it downloaded the 6th to the 10th URL, because the server assigned new resource to this client. As you can see here, the page number changed from 1 to 6. Okay, and in the result.buffer, by the way, if you call the report function of the client, it will tell the server that it has already done all of these tasks. And yeah, for example here, by the way, so let me see. Okay, maybe you can demonstrate that. So if something bad happens before it reports the task, what will happen? So now it actually successfully downloaded the file 11 to 5th. That does wait a little bit of time, but it hasn't reported to the server, and then you can call the report only for the next time you run this program. Okay, like this, and the server will now that you have already finished all these kind of tasks, and it will not assign this task to other clients again. Okay, That is our demonstration. Thank you for watching and hope you enjoyed this little program.